So in this video we'll be doing some past paper questions related to transformer. So in this question, the question says that figure 8 shows a DC supply connected to an input of a transformer. So this is a DC supply which is connected to this coil, and this is an iron core, and this is a secondary coil and connected to a galvanometer. So when switch S is closed, but that means like this, the needle of galvanometer deflects briefly. Briefly means for short period of time. So I'm just writing shortly, then returns to 0. So explain why this brief deflections occur. So when the switch is on, the current will flow through the coil, and the flowing current will produce magnetic field around the coil, and the magnetic field will change the magnetic flux in the secondary coil as well. So change in magnetic flux would produce EMF in it. So change in magnetic flux would induce EMF. I'm just writing it shortly. So, but as you know, it's a DC current, okay, and it's steady. It becomes steady at some point. So when the current becomes steady, the magnetic field will also become steady, and the flux will no longer change in the secondary coil. So it will not as the flux won't change anymore, so the EMS won't induce in it anymore. So I'm just writing the answer. When the switch is on, the current produces magnetic field in the primary coil. Due to this field, magnetic flux in the secondary coil changes. EMF is induced. When current becomes steady, no magnetic flux no longer changes, and so there is no deflection or no EMF is produced.